Let's get started on the speed run of the physics system, and this really is going to be a speed run. I'll try to do a more in-depth video at a later date. I actually had one recorded, but due to technical difficulties, that content was lost, and I just don't have the heart to redo it. So I'm going to try to get this as a really fast, high-level overview of the things you need to be aware of, and then followed up with a more in-depth video later. In my scene here, I have this zombie animation that I just kind of hacked together. It's definitely problematic. We've got this kind of like jump and then a kind of stumble step to a stand. And there's all types of issues here with the motion of the jump itself. And we're going to see how well the physics system can maybe make this go from a unacceptable animation to something that we could use. Obviously, the better your animation looks before the physics system gets involved, the better I think the end result will be. Now, one thing that we are going to be leveraging in this video is the ability to animate properties, object properties, and we haven't covered that in the previous speedrun videos. So I just want to talk about that first to begin with. So when we're working with the physics system, a lot of times we're massaging parameters and values of our object properties. So you're going to really want to go in and keyframe values for the entire time range. And so to do that, you actually have to go into the object properties to make sure that's enabled and it's red. And then you want to select the range in which you want this property to be keyframed. Now, one important thing to be aware of is that when you are animating the object properties, what track you have selected really doesn't matter. That's one thing that kind of initially kind of confused me when I first started trying to animate object properties. I could have the body track selected even though I have my foot point selected here, and then I could go ahead and set keyframe values if we wanted. So just be aware, this is one case where the active track doesn't matter when we're setting our keys. If there are times where your physics system doesn't seem to be behaving the way you're expecting, it's likely because you set the keyframe or the parameter value for a single keyframe versus a range of keys. Okay, let's go ahead and enable the physics system and talk about what we see. So if we go to the top center of Cascadeur, we see the little running man icon, and I'm just going to enable that. And when I do that, you're going to get this green character here to the left. If you're attempting to enable auto physics and you're doing it on a character that you've brought over from Maya using my Maya bridge, you're actually going to receive this error. And what that is related to is the fact that when my character is brought over from my plugin, the center of mass is on its own layer here called layer 0. I can rename that to something like center of mass. Or if you want, you could go into the layers themselves and add the center of mass to the body layer. That is where they are by default inside of Cascadeur. Otherwise, if you stay with layer 1 or the default layer, you just need to add another key to the end of the range so that the physics system can solve for the entire duration that the center of mass has keyframe data. So this is our physics system. This allows us to see what is the animation going to look like if it's adjusted by Cascadeur. Now, if we go over to the physics settings tab and we kind of go down a little bit to the auto physics, you're going to find a section here called ghost offset. And I believe the values look like this by default. This is the first thing that you should probably be aware of, is that there are times where you kind of want to compare the animations side by side, stacked on top of one another. So they have a nice ability to kind of just quickly shift this character from off in space so it's not getting in the way of your primary animation to right on top of your character by disabling that ghost offset. And then we have actual offsets, so how far is this character offset along the X, Y, and Z axes. And in this case here, if we disable this, you'll see here my character now doesn't have that fast shoot forward type motion while he's jumping. At the top of the physics tab, we also have physics gravity. And interestingly enough, if we turn our gravity up, that actually means our jump is going to be higher. He's having to exert more energy to kind of break gravity is the way I view it in my mind. So he winds up getting higher when he succeeds, versus if we lower our gravity down to something like 200, the character is not going to go as high. We're going to go with the default of 980, and we're going to go ahead and just offset this character again. Maybe I'm going to set him to be on the exact same Z axis, and then let's reduce the offset a little bit. When we enable that physics system, you're going to notice in the timeline, we have these color codes that appear above the tracks and right below the numbers here. So we have this gray. This gray value means that the physics system didn't solve anything for that given frame. So you're going to find the first and last frames to be gray. Then we have this green area. That means that the character has multiple points of contact with the ground. Those contact points are known as fulcrum points. Orange means the character is in the ballistic system. In other words, there's no points of contact with the ground. And then finally, we have a yellow. So the yellow means that we have kind of one cluster of contact points that make up one fulcrum point. So here we have just a single foot touching the ground. So the character is stable, but not as stable as if he has multiple points touching the ground. Now, with the physics system, like I mentioned a moment ago, there are a lot of ways in which we can refine some of these values here. Because we're going to have in the physics settings here, we're going to have these large sets of parameters we can adjust. But then a lot of those play off of what we actually have set at the individual object levels. So let's just see an example of that. I could go in and I could say that this foot here, I want to force it to have contact with the ground. So I'm going to select my time range here like this, and I'm going to go to my fulcrum settings here. And by default, it's just set to fulcrum, meaning the system is going to look at the height of the points in space as well as how much motion they have occurring to determine if this character might be touching the ground. So if the point is too high off the ground, the point will be considered in the air, and you can adjust that with this max height here. And then there's the max distance. If your point is moving too fast, it'll be considered to be in motion. So you could tweak these parameters if you want, but what I'm going to do is I'm just going to say enforce. So I'm going to force this to be touching the ground. Now when I do that, you'll notice that the timeline here turns yellow, meaning we're not really using the ballistic system anymore. And my foot is moving through space. So we just kind of get like this kind of weird slide happening. In this case, I don't really want this. I could go in here and say no fulcrum as a way to force the system to make sure that this character is considered in the air and not having a point of contact with the ground. So I definitely use this a lot when I'm keying my animations and I don't want to deal with fiddling when something should be considered planted or not planted. I just set the keyframes here. And again, I'm doing this with that apply on selected interval option enabled and then selecting the range in which I want that to occur. So let's get into the actual physics settings themselves. If we go to the settings tab and we go up here to the top, I'll just work my way down the list. There is an option to work on just the selected interval. Now, everyone should be aware that when you enable this, you're not going to see the physics system properly kind of refresh. You have to disable and kind of re-enable the physics system. Another kind of odd thing that can happen or that can be a little confusing here, I'm going to turn this off and I'll go ahead and re-enable this. If I say physics corrector off, so all of the different things the physics system can do are all turned off, I still see my character in the scene, but you will notice on the timeline we get this kind of gray bar going across everything. So if everything is off, you're going to still see that physics ghost. Beyond that, we have the show center of mass on interval, and that just means that we get this kind of red line here, and by default it kind of shows the path of the entire physics system. But if I enable this, it's only going to show it for the selected part of the time range. So a little simple option there. Then we get into the actual different layers of correction that the system can do. It's not just turn one option on. There's different things so that you can artistically choose what you want to have corrected or not have corrected. To start with, we have the main corrector called the physics corrector. It's on by default. Everything else is off. And then below that, we actually have a tab here or kind of a drop down or a rollout where we have all the different settings we can refine. The physics corrector's primary goal is to smooth out character motions related to the center of mass. It looks at our character as a whole, meaning if we kind of look at all the different kind of rigid bodies that makes it up, and it's looking at the velocity of those rigid bodies, and it's just trying to smooth everything out. It's really just dealing with velocities, not really angular momentum. That's a separate category. So if we select this right now, we can see the center of mass for the physics system is much smoother and more balanced than kind of what I have as far as my speeds go. So there are a lot of different parameters in here. I'm going to try to go through those in the order in which I think they're kind of related to one another. So the first thing we have is the smooth vertical force. As I mentioned before, its primary purpose of the physics corrector is not really dealing with vertical forces, but it can smooth those out. So if you're not really liking the way it's smoothing your vertical force out and you don't want to deal with tweaking numbers to try to get that to look better, you can just disable that. Now, if I enable this, you're going to see we have vertical force smoothness. If I turn this down to 0 and we look at just the center of mass trajectory here of the physics, you're going to see that we get higher highs and lower lows. And for this particular animation, we also have some pretty sharp and drastic changes in direction without any smoothing. If we turn this up, we're going to get, as the name kind of suggests, smoother kind of results. So it's doing kind of like an iteration of the motions themselves. I'm going to put these characters kind of right on top of one another so we can see kind of what this looks like. Beyond the vertical force smoothness, we get into the min vertical force and max vertical force parameters. And I will warn everyone that this is just my take on what these parameters mean. I could definitely be wrong. What these values in my mind are is related to the speeds at which the character can move. So I'm going to go in advance over to where we actually have a point of contact on the ground. When we connect with the ground, you'll see we get this kind of arrow. In my mind, this is the general kind of direction in which the mass of the character is coming down. And we're applying kind of a counter force to this. So we have a force kind of being applied from our fulcrum point to our character. And we have this min vertical force. The documentation kind of says that, hey, if we have this min value set to 1, it means the character cannot descend at all. And sure enough, when I set this to 1, you'll notice here that we get this flattening out of our trajectory right away. I mean, there's a little bit of smoothing happening here. So let's turn the smoothing off. So we get this. And then as we take this down towards 0, it allows the character to actually go further down. And let's get some smoothing back on because these two values play off the smoothness setting. And the lower that value goes towards 0, the faster that character can descend downwards. So if we want to stop someone from dipping really low to the ground, we could increase this value towards 1. Probably, I would think you'd never actually want to reach 1. You probably want some threshold there where the character could drop. And if you're doing anything fractional, I think I mentioned this elsewhere, but just always put in a 0 to begin with, so 0.8 or something. All right, and then on the flip side of that, we have a max vertical force, which is if we want to apply a really strong speed to the velocity of this character, is there a limit to that speed? So is there a max cap that character can actually traverse and the height? I'm going to jump over to this other scene that I have where we can kind of see this a little bit better. If I have this character here and I'm going to just hit play, you'll see the character launches really far in the air. I'm just going to mention real quick, the reason for that is because in the ballistic system, the time we're in the air really is going to determine the height there. So if I don't want that character going as far, I could just do Control T and reduce their actual air time, and then they're not going to jump as high in the air. In this case, though, having this extreme value makes it really kind of easy to play around with these min and max vertical forces. So if I hit apply and the character comes down, you'll see this character really kind of crushes into the ground, knees kind of blow out. So if I set this to 1 for the min vertical force, if we're thinking about something that limits the amount of that character dropping, you'll see that it really stops. If we set this to 0, so I have no smoothness happening, then it's just, completely still. So I could definitely take this value here and dial it to something like let's say 0.07, and we could see what that gets us here. So that now gives a strong impact, but at least my knees are not completely blowing out when the character hits. At the same time, too, there is a speed that our character is traversing, and I could play with this. Now, what's interesting here is that we would think if we want to minimize the speed at which this character is dropping, because they're coming down pretty fast, you would think you'd want to lower this. So let's do something like 0.05. But I believe this value is actually a limit to essentially the speed that this force is pushing the character back up. So I could go in there and set this to something like 15 and see if that helps with the knees as well. Let's set this back down to 0.1 for the minimum. So now our character, in theory, let's just get them back to where they were here. Here, this character is really crushing, right? But if I increase my max force enough, so let's do like 10 in this case, you'll see here I have more kind of counter force that can be applied to this character to stop them from going to the ground as much. Now, at some point, it's going to cap out because I don't know what the total number is that they're trying to apply force-wise. So you can really play with both of these numbers in each direction to kind of see what you can do to reduce the intensity of an impact. And again, you always have to start with the 0, and let's try 0.7. There we go. Beyond these smooth vertical forces, we have these use geometry constraints. Essentially, this is going to say, take into consideration the limb lengths of my character when I am solving for the physics system. Generally, I think you would want to have this on. I'm not sure necessarily when you'd want to have this off. But of course, all these parameters are there to kind of play with, see if one looks better than the other. Below this, we also have this geometry stretching setting here, which is set to 1, which says that these limbs can essentially be stretched to their max based off of the physics system. If in your animation, the limb is completely stretched straight, it's not going to unbend that knee. It's just going to make sure the physics system doesn't completely straighten that leg out. If you want it to be something less than a completely straight leg, you can set this to something like 0.9 or 0.8. That'll give a little more bend to the legs themselves. There is also this geometry min height, and what that's talking about is essentially your center of mass. If we go in here and we look at its transform values, you'll notice right now I can't actually see the transform value of this, and that's because I have the apply on selected interval enabled, and I had a range of keys selected, so it's not able to show me the values here because the values vary depending on what frame. But if I go to a single frame, or if I don't have that animation interval enabled, I can now see the actual height of this center of mass, and globally it's set to 9.5. If you're doing some type of animation where the character is getting like really down low, I don't even think here is low enough, but you know, maybe your character is posed in a way where you get your center of mass really low to the ground. This would be a way to ensure that it doesn't go too low. So if you find your center of mass really kind of hitting too low relative to the world y-axis, you can set this here to get that character to stay higher. Beyond that, we have the unite intervals. Essentially, the physics system is going to solve for the green areas, essentially these points where the character has contact with the ground, so the green and yellow, and then it's going to solve for the ballistics system. And it does that independently of one another, and then it kind of blends the two systems together. The results of those two together, that blending happens based off this fulcrum blending frames. At least I have found that that really seems to be as we go from ballistics to the ground, how many frames do we blend out the ballistics motion into the fulcrum motions. There may be times where you want the solver to kind of solve everything as one common unit versus breaking it up. That's where you could use that unite intervals option. I've only really found one case where that actually solved an issue I had, and it was an earlier version of Cascadeur, and I think it might have been more of a stability bug versus the need for this to be on. So when this is off, if you have a character that's landing on the ground really hard, you may find a foot, if the foot's not planted, kind of like swinging underneath the ground plane, and you could adjust this frame blending, increase that so that it blends into the land sooner, and then that will probably avoid that foot kind of like swooping down under the ground, because really it's like the ballistics animation is it's got that foot down low, and then it's blending into the fulcrum solve. All right, so that's the main three things we can enable or disable. Beyond that, we have the full cycles. So this is how many times does the system try to get your character to match the underlying physics solution that it has calculated. So if you set this to 1, it's going to be really fast to kind of do solves, but the accuracy may not be right there. I've never really found the need to like go up to 10. I've never turned that on and said, oh, wow, that looks way better. So we can do 5 here, and that seems to work. But if you really want to make sure everything is aligned as best as possible, maybe you could turn that up to 10 before you call your animation done and you bake it out. There's a fulcrum area indent. I honestly don't know if this has any real impact on the solve itself. My understanding is it's more if you have a character with really large feet and you're not seeing these fulcrum points here, you can kind of grow this out so that you can see this a little easier to understand where the contacts are actually taking place. The last thing we should talk about is the ideal snap. The ideal snap is going to allow us to kind of see where does the physics system want to put our character without being concerned of the foot placement in this case, or wherever your fulcrum points may be. So if I enable this, it's going to show me where the center of mass is putting this character as a whole. Now, I've modified my scene here so that if I scrub ahead, you'll see I've made my character just jump way too far given the amount of frames he has available. And you can see when I do this, I get some really strange poses happening here with my character on the plant pose. If I enable the ideal snap, I can actually see like this is where the physics system wants my character to be. And I'm going to disable that offset here. The way I kind of picture it is it's going to move my entire character's body around as one solid rigid body in space. That means there'll be times when you have the ideal snap enabled, you may see your character way under the ground or way above the ground. And then when ideal snap is off, the physics system then essentially, the way I picture is like pulls those limbs to the fulcrum points. And then when that pull is happening, it's really, in my mind, kind of the same as like if I took this foot here and I kind of drug this character forward, right? This is essentially what has happened. So this ideal snap is really nice for just giving you some sense of where your animation just may be really off base. If you see some really weird things happening with the physics, turn this on and then see where it wants the character to be. Now I can kind of say, oh, my character kind of wants to be here. So I'm going to take my animation and I'm going to go ahead and just modify this to be closer to that ideal position. So if I go in here and I enable that interval edit mode, now I can pull that back and say this should be the position that the character lands on. And then I can turn this off. And now I guess then that's going to be smoother. All right, so again, ideal snap, really good for troubleshooting what might be happening under the system before it gets the limbs placed to their final location. All right, let's move on to the next category. So we have the physics corrector, and then in my mind, the very next level beyond the physics corrector would be the angular momentum smoothness. Again, like the physics corrector, it's really looking at our character as a whole, one big blob, one big physics kind of rigid body, and is looking at the angular momentum of the character and is making adjustments. So if I enable this here and I hit play, we're not going to see anything by default. So this is our first parameter that we need to actually animate something in the timeline. And so to adjust our angular smoothness values, we need to select our center of mass, and then we need to tell the system where do we want this angular momentum smoothness to be applied. So I'm going to apply it to the entire animation. And the way it works is not really going to touch the first and last frames. And when I have the center of mass selected, we go into the object properties and you'll see we have auto physics, AM blending, and it's set to 100. 100 means it's not going to really have any effect. Before we change this, we're going to want to go in and actually turn on the ability to set this value for all the selected keys. And I like to really take things to extremes when I'm first seeing what the system does, because I'm going to just dial back my value. So let's go ahead and set this to 0 and watch what happens here. All right, so we get essentially this angular momentum of the character is being applied to the character as a whole. Once again, if we go in and we kind of turn on the ideal snap, we can see this a little bit easier, where it wants to kind of rotate the whole character around and then it straightens out at the end. All right, so now that I've done that and I understand what the extreme is, I can kind of decide how much I want to dial that back. So I'm going to go back into the settings here and really having values of maybe like 15 to 50 makes this better. Now, you'll see the feet are sliding all over the place. That means I forgot to turn off the ideal snap. Okay, so now we get a little more believable rocking of the body as a whole happening. This angular momentum smoothness also has a rollout in the physics settings here. And you'll see there's this AM dampening. Now, a value of 0, let's actually kind of take this to the extreme. Again, going to the extreme makes it really nice to kind of see what happens here. And in this, actually in this animation, it's not all that noticeable. Some animations, depending on how rough they are, you may actually see the character like rotate through themselves. They like spin a full 360. But the dampening, I found that 20 really keeps things pretty close to your animation. Imagine it's just how long does it take for the system to kind of smooth out, or the angular momentum to kind of come to a stop once it's enabled. And values less than 20 kind of help things just feel a little more alive. And I have found the few times that I've gone above 20 just using the presets here. I mean, we can always punch in whatever we want here, but something like 50 is actually really dampened things where even my core animation feels like angular momentum that I've naturally put into the poses has been lost. You will see I am starting to get some odd kind of twisting here. If I turn this on, I just kind of want to see. This is also where just going in and disabling lets you kind of see like what is this problem here? This problem apparently is not part of the angular smoothness sending this torso into twisting like this, because it's off right now and I'm still seeing the results of that. So I'd have to go in there and try to figure out what's causing that and make an adjustment. All right, so yeah, we'll keep that 15 or 20. It doesn't really seem too noticeable right now. Maybe I'll set this to something like 10. Let's see if I can just get that to be a little more apparent. Once we move past the AM smoothness, we're actually going to be dealing with values that we can set on a kind of rigid body segment. So we're not looking at the character as a whole anymore. We're actually whittling down to the individual limbs. And we're going to start with that compensation motion. So as the documentation kind of describes, the compensation motion just kind of looks at what is the kind of like main movement happening and how may these secondary rigid bodies kind of pull and rotate based off of that primary motion here. So let's go ahead and enable this so we can see what things are looking like. Now, it might be hard to notice, but when I enable this, there's a moment here where you see the character going from kind of a bright green to like a muted green. That means that the solve is still in the process of being calculated. And as you enable more of these, and depending on what your settings are, you may find times where you hit play. Like I have a tendency to almost just have the system running while I'm turning things on and off. And when you do this, make sure you're not evaluating what your parameter did as far as changing the animation until you know that you see a nice green solid character in the viewport. There's been times where I've seen this like muted green. I'm like, oh, I don't like the results of that parameter. And I set it back, but I never actually got to see what the solve did itself. So the compensation motion is going to be, again, something that we have to enable in a per limb segment, and when on the timeline we actually want to enable it. For demonstration purposes here, we'll just enable it for the entire scene. And this is one where I really don't want like the core of my body to be impacted by this. So I'm going to just double click and kind of just add it just to my upper body only. And then we'll select the kind of the time range. I'll go into my object properties, and then we have this compensation motion, and we have this muscle stiffness. Set to 100 by default, meaning that the compensation motion will not have any impact on this. And again, if we really want to see what the system does, taking these down to low values makes this more obvious. So let's go in here and turn off the ghost offset, and let's also turn off angular smoothness. Another thing that I like to do if I'm tweaking parameters out is disable one and have as few on as possible so that we can see exactly what that is adding to the equation, and then enable the previous values that we've had and we've liked. Now in this case, because the character is in such different places in space, it's going to be a little bit harder to actually see the results of this. So what I'm going to do is I'm going to turn my compensation motion off, and I'm going to do an initial kind of snap of my character to the physics system. So I'm going to do this with the auto fix option turned off, and then I'll hit the snap. That means it's only going to snap on those keyframes. And so now I get an initial kind of adjustment to my animation, and then I'll go ahead and turn on this compensation. It'll be a little bit easier to see. And let's just take this stiffness down to something like 5. And now we can see what this is doing. Obviously, again, when the values are too extreme, we can get some really crazy stuff happening here. But it's showing really, in this case, we get a little bit of a twitch when the character is first jumping. There's some momentum there that's causing a twitch. Pretty smooth here, and then we get a large kind of heavy impact, and the character kind of comes back here. So now that we know where the main muscle stiffness parameters are impacting things, we can kind of pay attention to that then as we dial this back. So let's take our stiffness back to, let's say, like 50%. And now, there's a little bit of a hit, but let's say that's maybe too high. Let's see what 20 gets us. Yeah, so if we look at the original character versus the animation here, the physics system, there's just a nice little extra amount of impact from that land. And then when he comes up, the motion there feels a little bit better. Okay, so I'm kind of liking the way that looks. Let's go ahead and enable our angular smoothness. And let's let that solve again. Yeah, so with that angular smoothness off, the character's head seems to stay pretty in line as far as we look screen left. Now with this on, notice here the character really kind of overshoots on that landing and then comes around. Let's go ahead and talk about the global parameters for the compensation motion. The upper body right now has a muscle stiffness assigned as a value of 10 to everything. So we can see that, again, that's a low number. I mean, there's some pretty bad motion happening there in the upper body at this point, but we can also adjust these parameters at the global level to refine how this kind of looks. So when the ZMP weight is at 0 or closer to 0, the more it's going to try to match the animation itself. And as we increase these values, the balancing system will be more apparent. So here we can see now we get some real craziness. So we'll probably want to slowly turn this up. Again, there's preset values, but you can punch in anything kind of in between. And for the ZMP weight, I believe we can go above 1. So we have this. Now, one of the biggest problems we have at this point, even if I kind of like maybe how extreme some of the torso motion is that there's just too much motion happening on those limbs. So what I want to do is I want to introduce some type of filtering of the momentum of the rotation of the limbs to kind of limit how much motion they can have. And you'll see we have essentially a rotation threshold and a translation threshold. So, when one segment of the body rotates, that's kind of pulling or moving the points around of the body in a translation way as well. Now, if we go in here, we change the default from 0 to 10, we can just take a look to see how this feels. So right away, things are not quite as extreme. Again, I'll put this down to 0. And really looking at this impact here at the end, if we go into this frame range here, like frame 24, setting this to 10, things are not quite so extreme. And then we can set this to 50. So now, even though our muscle stiffness is relatively low, we're getting something that is not completely disastrous. All right, so we can use this to dial back the strength of the compensation motion. And then on top of that, we also have the translation cutoff. Now, I'm going to do something interesting here. Let's see if I can recreate this here. In this case, I have my translation cutoff set to 10, and I haven't really actually seen this resolve the solve yet. You'll notice that my character stays this kind of muted green. And in the event log here, it's not going to actually say compensation motion is solved. So in this particular scenario, it seems that all the solve that the compensation is doing is trying to pull those limbs to moving faster than 10, and therefore it's just never achieving the goal. So we could go in here and play with these, but you'll see here that even if we can kind of limit some of that translation, we get some pretty odd behavior. So I've really focused when I've been adjusting parameters to kind of keep my translation values high, and then we can just dial in this rotation cutoff for something that mutes the animation a little bit more. Let's move on to talking about the secondary motions that we can add to our characters, because right now the compensation motion maybe is adding some interesting movement in our upper body, specifically the core of the body, but the arms are problematic. They're kind of all over the place and they've got some kind of weird extreme movements. And I'm hoping that secondary motion will help smooth some of that out. Now we actually have two different choices here. We're going to start with the secondary motion, the default one, the non-spring secondary motion. This is the one I've used most, so it's the one I'm most familiar with. We'll cover the spring secondary motion just briefly, but to be honest, I haven't actually explored it enough myself to talk with any level of confidence as far as like what you should look for. But we're going to go in here and go ahead and just assign some secondary motion to our arms here. So I'll double click on both of these limb segments. I'm going to bind a hotkey to that, just Control 3. so I can always select those really fast. We'll enable the secondary motion, and then let's go into the object properties themselves, and we're going to find the secondary motion rollout right here. And the way this is going to work is we have this local blending value. When it's set to 100, essentially, the secondary motion is not going to be applied to the selected points. And as we lower that down, essentially you can, at least the way I visualize it, is we have these rigid bodies underneath our character here, and they're going to be 100% physics in a way that doesn't really preserve the animation at all if we're at 0. And to demonstrate that, I'm just going to go ahead and set this to 0 because, again, I probably can't say it enough, I like going with the extremes to understand how things function. So here we can see the arms are just dangling at this point. There's 0 respect for what my animation is doing at all. Now, as I increase this value towards 100, it just means that the physics are going to be able to pull the rigid bodies away, but there's almost going to be a speed at which they return back to their original animation poses. So as I take this to something like, let's say 80, and we do this, now we can see it's much closer to what the animation was. And I want to go ahead and maybe take this down to, let's try something like 40. Let's see what that gets us here. Okay, so things are pretty wobbly. You may even see a little bit of like an oscillation, especially as we get here towards the end. We get this kind of oscillating motion happening. And to kind of combat that, we need to introduce some type of friction into the system. So I'm going to take this and let's go ahead and set this to something like, well, I didn't mean to do 500, but let's see what that does to our motion here. Yeah, so we still get some pretty extreme flappy upper arm here, which I don't really like. Let's take this air friction down. I was originally going to put in 50. I can't seem to stop hitting the 00 there. Now, we actually have two different parameters we can deal with. The air friction is going to be nice for kind of adding some drag or limiting the speed at which the limbs can move around. But then when we actually talk about something like an oscillation here, this is going to be probably more of just a dampening that we want to have to the animation as a whole so that the motion slows down faster. So we could increase this dampening here to see if we can kind of get those arms to kind of settle a little sooner here. In addition to the local blending, we can picture that just being how much can these limbs deviate from their position here of the character without really taking into consideration the movement happening through space. That's the way I kind of picture it. Where if we go in and we start to enable some global blending here, we can have it limit the effects of how far it can deviate relative to the world itself. So again, this is going to be very similar to the local blending. If I set this to 100 itself, we're really just going to be getting the main animation. And really, I'm not seeing what I expect. I expected this to look pretty much like the original animation, and I am seeing one of my mistakes here. So I've been setting these parameters here, but I've only been doing it for a single frame. So if you really have to make sure you're doing this for the range at which you want this effect to be applied. So here, when I select the range, you can see a lot of these values that I've been playing with were not consistent across the board. So let's try this again. Let's set our friction to 50, and I can't remember what we did for the dampening. Let's just go ahead and do 20, and I'm going to zero out the global blending so we can kind of get back to a good base. So now this is the results of our motion here. I'm going to go ahead and increase this global blending here. So let's set this to 50. And now you'll see that that reduces how extreme the limbs can deviate from their world positions. And what I was trying to demonstrate here a moment ago, if I set this to 100, that really should just essentially remove any of that secondary motion. I can go in here and I can turn this off, and the poses should pretty much match. Now, again, what I like to do when I'm playing with these values is kind of focus on one thing at a time. So I'm going to turn the compensation motion off, and I'm going to stack this with my character here so I can really see the deviation between the two. Now, obviously, once you find something you like, it may not look exactly the same once you turn things like compensation motion back on, because all these systems are kind of playing off one another. But this is probably like a nice way to kind of get familiar with what these parameters do. So let's go back here again, set this global blending to 0, and just go ahead and hit play, and we can see what that difference is between these two. I might even go into my playback settings here and just reduce this time factor a little bit so we can see this in slower motion. So you can really start to see a little bit of the, if we really look at the wrist here in particular, the drag happening here. All right, so that is the secondary motion. I think it's pretty easy to work with. Just, dialing those numbers down until it's too extreme and then pulling them back a little bit. Increasing that air friction is going to give them a nice drag as they go through space. They're not going to fly all over the place. And then increasing that dampening so that the oscillation effect isn't so noticeable when we kind of get to a settle. Let's go ahead and turn off the secondary motion and talk about the spring secondary motion. This is the one that I'm the least familiar with. Oh, I should mention also real quick, you'll notice with the secondary motion, there are no actual global parameters. It's really just done at a point level. So we don't have to worry about an extra set of parameters we're looking for that one. But the spring secondary motion does have a global set of parameters, but we're going to jump right over to the object properties themselves. And I think what I'll do this time is I'm going to apply this to, let's say, my entire left arm will get this and just the core or the root of my right arm. So we can kind of see a little bit of a difference between these two. And I'm going to go down into my spring secondary motion rollout. And the first thing I need to do is I need to actually specify that I want the spring secondary motion to be applied to these objects here. So I'm going to go ahead and say dynamic. We'll hit play and we'll see what we get here. And I'm not seeing anything. That's because I forgot to enable it in the actual solver. So here we go. And now we get this motion itself. With the right arm, it becomes really obvious to see that secondary motion because we just have the root of the limb causing everything to kind of oscillate below it like it's one big rigid object. So let's go ahead and see what we can do to dial back some of these issues that we're having. So I think really for this, the right arm is going to be the easiest to kind of see what's happening since it is just one large limb segment. So if we look at this, we really kind of have two different categories. We have the rotation values of the stiffness and dampening and then the translation values. We can kind of visualize that at the root of this arm, the secondary motion is going to cause some type of amount of rotation. And then at the end, this wrist is going to be impacted by that rotation instead of be moving through space. And then that wrist could be, let's say, attached to a spring to where the animation is, so that that wrist is going to want to try to pull that animation back. So the point of the wrist is moving because of like a translational value, and that's going to be the stiffness and dampening values. And then the rotation stiffness is going to kind of be impacting the base here. At least, once again, I don't know. This is just the way my brain is kind of thinking about it. So when we talk about the oscillation, the rotation stiffness and the translation stiffness will both have an impact on this. Let's just kind of watch the last kind of part of this animation here where we can really see that oscillation happening here. So we get this. Now, if I go in here and I increase my translation stiffness, that means, again, kind of picture this spring. The spring can't stretch as far, so the amplitude of it is lessened, but it is going to vibrate more. So we'll just set this to like an extreme value like 100. And now when we hit play, we can see that arm is not swinging nearly as high. Let me pull back a few more frames on this. And we're getting this kind of inner vibration happening to the arm as a whole, all the way through. Now, if I turn this down to 0, now the spring can stretch even further. It's going to always do some kind of pulling back. But this translation value is not really having a drastic impact as far as the overall oscillation that we're seeing now. That's really coming from the core of the arm in this case, and that's being driven by this rotation stiffness. So the same thing, again, kind of applies here, where we can say that if I increase this stiffness, it's maybe not going to rotate as much, but it's going to oscillate more. So if I want to dial back this rotation oscillation, I can just lower this number. So let's do something like 40 and see what we get here. So now we get a much softer swing happening. Maybe the amplitude is too much at this point. So let's try splitting the difference. When I'm also punching numbers in, I like to go extremes and then splitting in half. So if I went from 80 to 40, I'm going to do 60, and then whittle my way down into more refined numbers. So now we get something like this. Now, the reality is that I want to do more than just play with the rotation stiffness to try to dial back that oscillation. I really need to probably increase my dampening effect. So as I increase dampening, the faster the effect is going to kind of fade out. So let's take this up to something like 150 and see what that gives our system here. So now we get something that's softer. Now notice the arm is really swinging into the body at this point. That wrist, if we can think about this at the end, I have no translation stiffness. The default is 5. So let's go back to the default and see what that gives us. All right, so let's try taking this up here, and let's try setting that to something like 30. Yeah, now it is probably oscillating too much. I want to go ahead and probably get that translation dampening enabled as well. All right, so now we're getting something. There's still a little bit of like a wobble there, but it's feeling more natural at this point. Let's actually see how this looks for the entire animation. And let's just pull that back. Now we can see I've really made the limbs too soft. I think I need probably, that could be in effect really, man, that could be a lot of things. I probably should have been looking at this animation as a whole before I did this. So let me pause the video here and just find some good numbers that seem to be working. I'll just show everyone as I'm doing this. If I take this translation dampening down to 10 from, let's say, 50, that was the value that was really having a major impact as far as how much the arm could move in this case. All right, so I have something kind of like 60, 150, 5, 10, and also enabled this global rotation matching. So initially, it's just looking at the angular rotations of the character relative to the body itself. It's not really taking into consideration its movement through space. So I'm going to go ahead and just turn that on, and that kind of softens things a little bit. Now, the reality is I really shouldn't even be focusing on this right arm for trying to get something that looks good, because this was just kind of an experiment. The right arm just only having one point of contact makes it really easy to kind of see how these values play around with one another. But I would think for the limb segments, you're going to probably really want to kind of have that secondary motion traveling down the arm. So I would really want that on the forearm. And to a lesser extent, I'd want that on the wrists. I mean, having a little bit of overlapping action on the wrists can be nice, but I feel like, at least for my style of animation, a lot of times it makes things feel weird. So when I'm doing secondary motion, again, I don't really use the spring much just because I haven't explored it as much. But when I do the secondary motion, I tend to really not let my wrists deviate from my animation too much. So I turn those off. So with that being said, let's just take a look to see what the left arm is doing, because this is going to be a better representation of how the values play off of one another. So there we have this effect happening, and you can see the hand itself gets a little weird shaped. Let's go back and actually try to bring in these values that we have for the left arm into the entire right arm and see how things look. So 60, 150, 5, 10. I'll try to remember that. All right, now let's see what we get with this right arm with everything behaving. And I'm not seeing the effect because I also need to enable dynamic for those new points that I just brought into the equation. Yeah, so there's a drastic difference there with these limbs here, depending on if I'm just doing the root of the chain or if I'm doing all of the objects in that chain. So let's just go in here. I'm going to play with this just a little bit more. Let's set this translation dampening back to 5 to see what we kind of get. All right, beyond the object properties, we do also have values here for the spring secondary motion. And like I said before, I'm not all that familiar with the system, so I'm not going to really speak on this. But even without playing with these values, I can, in my mind, say that obviously this is something that impacts everything. So if I'm seeing something globally problematic for my character, going over to the physics tab might be the place to kind of tweak what some of these parameters are doing. All right, so I've gone in and I've just enabled everything. I actually went in and took my angular smoothness and increased the value a little bit. I found that there's a kind of wobble that I didn't like when I enabled that, which just meant the intensity of that effect was a little too high. Also, I went in for my spring secondary motion and I made it actually non-dynamic for the first bit of the animation. When it was on, I wasn't getting the hands lifting in the air. They were kind of just dragging behind, and I didn't want the secondary motion to mess with that too much. So I disabled that and then enabled the spring secondary motion at this frame here so that I could get that effect at the end. Also added the primary secondary motion to the head itself. And you can mix these two together, so there's no reason that the arms couldn't have both of these. But, you know, the more layers that you have, the more you have to try to troubleshoot what's causing a visual oddity when you see one. Now, I am seeing kind of an odd little kind of hiccup with the knee right here in the physics system. I'm going to go in there before I do the bake and just see right there, there's a little bit of a twist. I'm going to see if I can give a little bit of a reposing to my knee here to stop that from happening. So I'm going to take that and just pull that out a little bit. And then let's see if, yeah, it's still popping a little bit. I probably would be easier to fix that post-bake, but there we go. Let's go ahead and do the bake. So this time I'm going to make sure that I actually have the fixed interpolation enabled so that when I do the bake, all of the keys match. And I'll just go ahead and hit snap and say yes to this. So it's going to disable everything and kind of reset my settings here when I'm done. And now we can go ahead and hit apply. And there's my animation. Now I could go in and I could fix any little issues that I see. So the one thing I'm really seeing here is this hand is vanishing under the leg there. We got some problematic clipping. So I'll go in and just kind of find this point that's happening. So let's take this and I'll enable the interval edit mode and just kind of pull this hand out a little bit so that it avoids that clip. And then we have some clipping again at the end here as we go into the leg, I think. Yeah, so right at the very end, there's a clip on this hand. So let's grab that. And nice thing here with the fixed interval edit, it's still easy to kind of refine these things. So let's try something like this. And still clipping a little bit. I'm going to undo this. And let's take and grab a bigger range here. There we go. I am also seeing this leg kind of hyperextending. Right there we get a pretty extreme pop. So I'm going to go try to fix that up. And let's remove this point here. So I'm just going to kind of try to roll that leg a little bit. Oh, and now I saw some clipping on the right side that I had missed before. And again, I think I'll just do this from the last major key. Yeah, it looks a little strange there. We get some kind of dip. I think what I'll try to do is just rotate that from the root of the arm. Still getting a clipping there. Lots of ways to refine this. I'm gonna actually look at the trajectory of this animation here. Yeah, we pop in there. I'll just smooth that out a little bit. All right, so this wraps up our video on physics inside of Cascadeur. Hopefully you found some useful bits of information in there. We can see the before and after refining our animation. So the original animation, super rough, really fast to block in. The physics system really brings that to life. Now, the one thing I would say is that if this zombie here was supposed to kind of be doing a lunge and those hands were out, the overlapping action, everything, I've kind of lost that with my arms themselves. So I'd really probably either want to dial back what the overlapping action did to those hands, or maybe do some refining after the physics system to bring that back into play. But other than that, still, I think pretty incredible as far as how quickly you can block a motion in and then refine that, giving the animation something that actually feels realistic and believable. If you like my content, please make sure you like, subscribe, and leave a comment, and good luck animating. I'll see you in our next video.